Welcome to episode 8 of our ComfyUI tutorial series. Today I want to talk about Flux, the new model that is currently my favorite. I'll show you how to install and use different versions of it, such as the Dev and Schnell versions. I'll compare the different models, highlighting which one is better, faster, and which settings work best, among other details. Flux is created by Black Forest Labs, a team of researchers and engineers who have developed various models in the past and previously worked for Stability AI. They have now introduced the Flux version 1 model family, which performs quite well but requires a good computer for decent speed. It supports different ratios and resolutions up to 2 megapixels. They offer 3 versions: the Pro version, which isn't available for download, and the Dev and Schnell versions, which we can download and use on our computers. The Pro version is only available through the API. The Dev version produced the best quality but requires more resources, while the Schnell version is the fastest but has lower quality compared to Dev. The Dev license is non-commercial, while Schnell uses the Apache 2.0 license. I checked the Dev license on their Hugging Face page, which includes a license.md file. It states, "We claim no ownership rights in and to the outputs. You are solely responsible for the outputs you generate and their subsequent uses in accordance with this license. You may use output for any purpose, including commercial purposes. However, it also notes you may not use the output to train, fine-tune, or distill a model that is competitive with Flux. So as I understand it, you cannot use the Flux model itself for commercial purposes, but you can use the images generated with it commercially. You also cannot use those images to train a new model that competes with Flux. For the Schnell model, you can use both the model and its output for commercial work. Again, this is my interpretation, so you should review the license yourself for complete clarity. I also asked ChatGPT to look online and explain the license for each version, so you can pause and read this information if you want. I will put all the links in the description. Here are some examples from a GitHub page. We have several versions: the regular version, which is FLUX Dev, the largest version of Dev; FLUX Schnell, the smallest version; and the simpler to use versions, which are floating point 8 versions that are smaller and don't require complicated workflows. Both Dev and Schnell have these smaller versions. To make it easier for you, I will show you how to quickly install each one, and you can decide which is better for you by the end of the video. For the FP8 version, download the models and place them in the checkpoints folder. You can download them from the links provided, but I will also include additional links. From this page, you can download the FP8 version of the Dev model, which is 17 gigabytes. Download it using the button provided. Next, navigate to ComfyUI, then Models, and place the files in the checkpoints folder. I will also download the Schnell floating point version and place it in the same folder. It has the same size, but is the Schnell version. Remember, Schnell means fast in German. After the downloads finish, which might take a few minutes depending on your internet speed, I will first show you some quick workflows for those who are impatient, and then I will explain how to build that workflow from a simple SDXL workflow. Save these images somewhere on your drive. They also include the workflow. I will do the same for the Schnell image. Next, open ComfyUI, click on Manager, and then select Update All to update ComfyUI, so it adds the new nodes that recognize Flux models. After restarting, you should have the latest version. Click Load and navigate to where you downloaded the images for both Schnell and Dev. Look for the checkpoint in the name to identify the floating point 8 version. I will load the Schnell version, which is faster. It should show you the Schnell model. If not, select it from the list. Running the workflow should give you an image like this. Now let's load the Dev version workflow and run it to see what we get. The result is this anime image. So that was the short version. I'll show you later in the video how to install the larger 16-bit Dev version as well. To recap the short version, download the models, place them in the checkpoints folder, download the images, load them in ComfyUI, and run the workflow. It's pretty simple. Let's explain it a bit more. Now, let's load a basic SDXL. You should have one working by now, but you can also download it from my Discord server. I will show you how the workflow differs compared to SDXL. First, we need to load the Flux model. I will start with the Schnell Floating .8 version. Another difference is the empty latent image. It works better if we choose an empty SD3 latent image, which we used in another episode for Stable Diffusion 3 Medium. Delete the old one and reconnect the new one to the latent input. I will change the color to purple so it's easier to see. I'm also changing the color of the positive prompt to green and the negative prompt to red, as these are the colors most people commonly use. I'm deleting the negative prompt since Flux doesn't support it. Then I'll right-click and choose Collapse to save space. As you might recall, each model has recommended settings. On the examples page, you'll find the settings for the K sampler. The CFG needs to be set to 1 because when it is 1, it ignores the negative prompt. For Schnell, being the fast version, it only needs 4 steps to run. The sampler should be set to Euler, and the scheduler should be set to simple. Let's give it a test to see if it works, and here's the result. Not bad for only 4 steps. The first time you try it, it will take longer because the model needs to load, which took about 13 seconds. However, after that it should be quicker. On my RTX 4090, it only takes 4 seconds, which is great. I'll save the workflows from this video so you can load them quickly, and you can easily download them from my Discord. Now, let's load the Dev Floating .8 version. This one has the same settings, except that the number of steps should be higher, around 20, 30 steps. I'll go with 20, then I'll make some space for a new node called Flux Guidance. The default value is 3.5, and since our CFG is locked to 1, we can use this guidance node to influence the image. It's somewhat similar to CFG, but not quite the same. This node doesn't affect the Schnell version, it only works with the Dev version. Connect the conditioning from the positive prompt, and then connect the conditioning to the positive input on the K sampler. If I run the workflow, you'll see that the first time it took 24 seconds because we have more steps now. However, the second time I ran it, it only took 14 seconds. On an older PC with 6 gigabytes of VRAM, it was still runnable, but took around 6 minutes. So having a newer, powerful NVIDIA card will definitely help with the speed. I'm also saving this workflow so you can download it. Now, let's test the Flux guidance a little. I'll use a prompt for a painting of a gnome and choose a fixed seed so we can compare the results. Running it with the default value gives us this result. If I change the guidance to 3, you can see the difference. You can go lower, but at some point, it will start to degrade the image. It might create a nice painting effect, but it's best to experiment to find what looks best for your prompt. The result varies depending on the prompt, but I usually lower the value for paintings. Sometimes higher values can also help, and you can use values between 1 and 100, though values above 20 have less effect. Higher values might improve text in some cases, but the default value is usually a good starting point. I'm loading the Schnell version workflow again since it's faster. Someone asked if Flux can use styles, and yes, it can. But first, make sure to check episode 7 to get the extra nodes and set up the styles correctly. I'm adding the multiple style selector node. Next, I'll convert the clip text encoder to text input and make some space for another node. I'll add an easy positive and then a text concatenate. Just like in episode 7, I'll connect positive to text A and positive string to text B. Then I'll connect the string to text input. This way, our prompt, along with the prompt from the styles, is combined in this node before going to the clip text encoder. I'll collapse and rearrange the nodes to make it clearer. Now I can add a prompt and select one of the styles, such as cartoon cute. When I run the workflow, it seems to work just fine. I'm changing the seed to fixed so I can compare the style influence. First, I'll add a prompt like a gnome in a magical forest. Then I'll deactivate the styles by selecting no style. Running the workflow gives us this image. If I switch to a new style with the same seed and prompt, such as the Impressionism painting style, the result should be different, and we get something like this. From my tests, Flux recognizes fewer art styles compared to SDXL, but it still influences the image since it uses additional prompts. It might not capture the exact style if Flux doesn't recognize it. Let's try another style such as Portrait Cinematic from photography. The result is a more photographic look of the gnome. Finally, let's test a different style like biomechanical art to see how it influences the result. We get a sci-fi gnome, which is pretty interesting. I will create a more compact version to make it easier for beginners to use. You'll be able to just download and use it. First, select all the nodes except the Save Image node, then right-click and choose Convert to Group node. Give it a name, and now we have a simplified interface. I'll hide the negative prompt from the interface since it's not used in Flux. You can try adding phrases like no signature or no watermark to the positive prompt. Sometimes these can work. You can add from 1 to 4 styles here, with the first one being the most important, so the order does matter. From the width and height settings, you can adjust the size. Since we use the SD3 empty latent image, it handles multiples of 16, making it more compatible. I'll make some more changes and adjustments, and you'll be able to download a version that looks something like this. I want to test both the Schnell and Dev floating point 8 versions, so I have the Schnell workflow on top and the Dev workflow on the bottom. I want both workflows to use the same prompt, so I'll convert the positive prompt in both to text input instead. You can add a primitive node and connect it to both workflows with the text encoder. Alternatively, if you have the nodes from episode 7, the Comfy Easy Use node already includes the positive prompt in green and ready to use. I'll add a prompt here and start with a fixed prompt for both workflows. I might change it to increment so I can test with another seed while keeping the same seed for both workflows. I'll create a more compact version, leaving only the generations and the prompt visible on the screen. The first one will be the Schnell version, and the second will be the Dev version. If I test the prompt, green sphere on a blue cube with a black background in 3D render style, both versions seem to understand it. However, for some of the seeds, I ended up with a blurred image, as seen in this case. I'll show you how to fix this by changing to a different sampler and scheduler toward the end of the video. I recorded this video over a few days because each day, new information, versions, and improvements emerged online. I've tried to include as many updates as possible in this video. For a portrait of a woman, I got nice results. The Dev version seems to be a bit more realistic, but if you want even more realism, there is now a realistic LoRA available for Flux. For a portrait of a Viking in the rain at golden hour, the Dev version produced a more realistic look and successfully captured the rain, which the Schnell version did not. For a witch holding a sign with text, the Dev version nearly got it right on the first try. On the second try, both models produced the correct result. While it's not perfect, it's the best offline model I've tried so far. For a cartoon warrior cat knight, the Dev version handles the swords and shield better. I also noticed that the Dev version generally has fewer mistakes with hands and details compared to the Schnell version. For a penguin eating ice cream with a polar bear in the background, the Dev version did a better job once again. The Schnell version failed to render the ice cream. For the prompt with a fox and a bunny, the Dev version has more details in the image. I then wanted a portrait of a crocodile with a wanted poster on the wall. I decided to add $1,000 reward to the poster and wanted the crocodile to actually be featured on it. If you're clear with your prompt, you can get quite good results. Once again, the Dev version seems to be a bit better at this. I also tried a simple prompt like stairs to heaven in concept art, and the styles appeared a bit different. Then I got hungry and tested a photo of a hamburger, which resulted in a quite delicious image. Next, I wanted a small flag that says free, and wondered what if the flag was white, like a surrender flag. The model was able to incorporate all these elements, demonstrating quite good prompt understanding. I wanted to do some vector style design as well, and again, the Dev version tended to blur the image for certain seeds. Check later in the video to see how I fixed that issue. However, you can create some nice vector designs with Flux. For the Dev version, I got a charming, cute cat. It's also quite good for logos from simple to more complex designs. You can experiment with styles and gradients to come up with some great logo ideas. You can also create some great photos for your presentations, like cool mockups. As you can see, the Dev version still tends to produce better results. If your video card can handle it and you're willing to wait a bit longer for generations, it's definitely worth it. For the oil painting of a king on a throne, Both versions produce some nice results, but I still think the Dev version is a bit better. Who would have imagined that you could get a digital painting of something so complex in just a few seconds on your computer? It's also quite good with hands. So far, the hands are better than on any other model I've tested. So, remember, I mentioned I'd show you a fix for blurred images. The issue is with the Dev model. If I use a specific seed, I get a sharp, clear image. However, testing subsequent seeds often results in blurred images, which can be quite frustrating. What fixed it for me was changing the sampler to DPM plus 2M and the scheduler to SGM uniform. Testing the same seed now yields a sharp image. I also tested the previous seeds and they worked just fine. I'll probably update the workflows on my Discord to include these settings so you don't end up with blurred images. So we've tested the floating point versions of both Dev and Schnell. Now, for those with top-of-the-line video cards and plenty of system RAM who want to try what is considered the best version, here's how to set it up. The regular version works a bit differently. You'll need some additional clip models to place into the clip folder. First, go to this link and download these two models. Navigate to your models folder, then the clip folder, and save the files there. Next, get the second model, which is the larger one. If you don't have enough RAM, you can use the version with floating point 8 inches in the name and place it in the same folder. However, the floating point 16 version is recommended if you have more than 32 GB of system RAM. You'll also need the VAE file, which you can find here under the name AE Safe Tensor. Download it and place it in your models folder, specifically in the VAE folder. For the actual Flux model, this time you need to place it in the unet folder. Download this large model, which is 23 gigabytes, and will take some time to download. Save it in the models folder, then into the unet folder. Finally, you need one more thing. Save the image that includes the workflow, load that workflow, how it looks. So this workflow is a bit different from what we're used to. I'll give it a test. You can find more information about where to place the models on this note. The result is this anime image. In the tips, you also have the option to change the D type, which might speed things up depending on your setup. For me, the default option was faster, but you can change it from here. This setup includes a node that loads both clip models we downloaded, and the VAE is separate compared to the floating point 8 version we started with, where the model included all the clips and VAE, making it simpler to use. This version is a bit more complex. We still have the Flux guidance, but there's an additional basic guider and a custom advanced sampler instead of the K sampler. It also uses an empty latent image with width and height adjustments on the side. This setup seems more complex, with automatic adjustments based on resolution, which can be confusing. I always try to simplify workflows, but others seem to make them more complex. It would be nice to have a single node that handles all these steps. The first time I ran it, it took over 35 seconds to generate, but the second generation was completed in just 18 seconds. Now let's test both the regular Dev version, the large one, and compare it with the floating point 8 version, which is a bit smaller. I'll convert the positive prompt text encoder to a text input so I can use an easy positive node, allowing me to place the prompt in one location. The seed will be fixed. I'll arrange the setup so you can see both generations and the prompt. I'll place the regular version on the left and the smaller floating point 8 version on the right. For the first try, we see less detail in the eye with the floating point 8 version. For the gnome, the results are quite similar, but the regular version has more detail, like the moon having more details. For the pixaroma book, both versions got the text right on the first try. The same goes for the sign on an exotic island with only some small differences. For the burger photo, the results are again very similar. So most of the time, it doesn't really seem worth using the regular version since the results are comparable. It depends on the prompt. Sometimes you see a difference and sometimes you don't. The floating point 8 version can do nice illustrations and decent photos. And with the new realistic LoRA, you can achieve even more realism. However, some people have noticed a small line on the chin in photos. It handles a girl in the grass better than Stable Diffusion 3 and can even manage a yoga pose. though I used a which as the subject. Overall, the regular version is a bit better, but not by much. Given the extra complexity in the workflow and the increased generation time, I'll probably stick with the floating point 8 version most of the time. I was about to finish this video when new updates came out. For those with lower VRAM, there are now faster versions of Flux. The quality is a bit lower, but at least you can check if it runs on your PC. The new version is NF4, which I believe stands for Normalized Float 4-bit. I'll show you how I managed to install both the Dev and Schnell versions on my ComfyUI. Download the Schnell version model from the link in the description or on Discord where it's more organized. Next, in your models folder, look for the checkpoints folder. This version worked for me when it had BNB in the name. I tried a version without BNB in the name and it didn't work, so make sure the name includes BNB. Do the same for the Dev model. These models are smaller than the floating point 8 versions and only take up 11 gigabytes. After downloading, you should have both models ready. To make it work on ComfyUI, you'll need a custom node called Bits and Bytes. As of making this video, it wasn't available in the manager, only in the dev channel, so I'll install it manually. You'll also need to install Bits and Bytes. Go to your ComfyUI folder and look for the Custom Nodes folder. Here you can see all your installed custom nodes. If you ever install a node and ComfyUI stops working, you can delete the folder for that node from here. Next, go to the address bar in the Custom Nodes folder, type cmd, and press Enter. This will open the command window in that exact path. Use the command git clone followed by the link to the node's GitHub page. Press Enter, and the node will be copied to your PC. Now, you need to install Bits and Bytes. In the command window, use the command pip install ubits and bytes and press Enter. It shows here that I already have it installed. If it doesn't install for you on the portable ComfyUI, try this command. Go to your update folder, type cmd, and use the same command. Make sure to close all command windows you have opened, or ComfyUI will not start. Then run ComfyUI. To ensure everything is working correctly, update ComfyUI using the manager and select Update All, then restart ComfyUI. Here's the workflow for the Schnell Floating Point 8 version. To make it work with NF4, you'll need to make a change. Search for NF in the nodes, and since we've installed the new custom node, you should see the checkpoint loader NF4 in the list. Add this node, which looks similar to the load checkpoint node. Reconnect the nodes as you did with load checkpoint. Connect the model to model, clip to both positive and negative encoder, and VAE to VAE decode. After making these connections, you can delete the load checkpoint node. Ensure you select the Flux Schnell NF4 version from the list. When you test it, you might notice that the first time it's slower, but after that, it should take around 3 seconds on my RTX 4090. You can now save the workflow. Next, let's set up the version for the Dev NF4. Select that model from the list, change the steps to 20 to avoid any blurred images with the Dev version, switch to DPM++ 2M with SGM uniform. After making these changes, do a quick test to ensure everything works correctly. For the Dev version, you can add the Flux Guidance node, which provides extra control. Connect this node between the positive prompt and the key sampler. Now, let's test the Floating Point 8 model alongside the NF4 model to compare the results. First, choose a fixed seed for both models to ensure a better comparison. Next, convert the positive prompt to text input, so you can use a single prompt for both workflows. Arrange the images so you can see both side by side on the screen along with the prompt. Place the Floating Point 8 version on the left and the NF4 version on the right. For some prompts, there's a noticeable difference between the images, while for others, the difference isn't as significant. Generally, the Floating Point 8 version seems to have more detail. For instance, in the robot image, it appears more detailed around the eyes and the texture is a bit sharper. For some prompts, like the burger, the textures are almost the same, but the Floating Point 8 version shows slightly more texture. With the cute hamster, the differences in sharpness and detail are more evident, with the NF4 version being less sharp. In the dragon prompt, the images are similar, but the horns look different. For the pirate face, it's noticeably sharper in the floating point 8 version. The monkey image is again quite similar, with a bit more texture in the wood in the floating point 8 version. For the magician bunny, the bunny is sharper in the floating point 8 version. So depending on your preferences, you might find the floating point 8 version more appealing. For the portrait, it has more texture on the nose and forehead. For the last part, since I have already extended the video a few times to include the latest updates, I want to discuss using LoRA with Flux. You need a LoRA that matches the base model. So in this case, use the Dev version. I'll use the floating point 8 version for this example. XLabs has released a realism LoRA for Flux. I found a version that works with ComfyUI on this page. It's quite small, so you can download it and place it in the following folder. Go to ComfyUI, then Models, and look for the LoRa's folder. Save the LoRA there. I found a prompt that better demonstrates what this LoRA can do. First, let's hit refresh so we can see the new downloaded model when we add it to the workflow. But before adding the LoRA, let's test without it using a fixed seed. The result is this image, which has a plastic look and isn't very realistic. I'll copy this image and paste it next to the new results for comparison. To add the LoRA, do it as usual. Add a load LoRA node and select the LoRA from the list. Place the LoRA between the load checkpoint and the clip text encoders. Instead of a direct connection, route the connection through the LoRA. Connect model to model input, clip to clip, then clip to positive and clip to negative. Now, let's test it to see any differences. With the realism LoRA, the result is much more realistic. If you want to generate more realistic images, this LoRA can help. I'll try another prompt, like a portrait of a dog. First, I'll bypass the LoRA to see how it looks without it. The result is quite realistic. I'll make a copy and paste it. For some reason, it kept loading different images instead of pasting the correct one. I had to click on the arrows to find my pasted version. It seems I had a folder in my input directory with more images I had pasted in the past with the same name. I cleared that folder to fix the issue. I'm going to the load LoRA node and right-clicking to bypass again to activate it. When I test it now, the difference is subtle but noticeable. You can see that the image on the left with the LoRA activated appears more realistic. In this video, I tested 5 Flux models. As you can see, Flux version 1 comes in different sizes and versions. Generally, the larger the file, the better the image quality, but it also requires a more powerful graphics card with more VRAM and more system RAM. Here, you can see the approximate time it took for each model to generate the images. I tested them on an RTX 4090. As a general rule, the Dev version offers better quality than the Schnell version. Additionally, the smaller the file size, the faster it will generate. If you don't have a high-end graphics card, start with the Schnell version. If your graphics card is decent but not the best, you can try the Dev floating point 8 version. On some cards, the NF4 version might be the fastest option. It took me a while to organize everything, but now you can find all the workflows for episode 8 and earlier episodes on the Discord channel, Pixaroma workflows. I've organized them by model. For example, the full version includes an easy access download link for everything you need and instructions on where to place the files. You also have a preview of the workflow, which you can download and load into ComfyUI using the load button. I've also created workflows for the Dev version and floating point 8, complete with settings and other useful information. I've included compact versions for most workflows, added LoRA, and more. You can test these for free on various websites. Sometimes they can be busy. If that's the case, try the second website, which should load fine. You can add a prompt, run it, and see that it's waiting for a GPU to become available. Once it is, you'll get an image that you can download. I have a small request. 78% of people who watch my videos are not subscribed. If you could hit that subscribe button, it would really help. If you found this video useful, please leave a like and a comment to help my channel grow so I can create even more content for you. Thank you for watching and have a great day.